Y or Z or X, you're rotating Z. So I'm basically saying rotate this angle around the Z plane. Okay, so it rotates the whole screen to do that. Now remember, I've saved everything else on the screen, so that's not going to be affected, the matrix for those. So I'm saying rotate the screen and then pop back on our image, and then I'm going to rotate the screen back to where it was for everything else to be drawn once this image is done. I then set the color. So remember, we've got this color array with red, green, blue, and alpha, and it's a 4F, so it does take the 4 points, the GL color call here. So I just literally go and pull the value from each of those array elements and pop them into color, and that really allows us to tint. So whatever color you put in here, it will tint the color of the object that you've got. Again, there's far more information on the internet about how the tinting works, how the blending of colours work, and so on. So definitely, again, Nihi's got information on that, so worth a look. The last one here being alpha. So again, you could keep all of these as 1, 1, 1, which means there's no real effect to the colour at all, but you could set alpha to 0.5, and that would make it 50% transparent. So we set the colour, ready to do the drawing. Okay. We then enable a client state here, and this client state basically saying, because we're passing in texture coordinate array, it's saying we are going to be using a texture coordinate array, and I want to enable that to happen. So it's really saying that OpenGL can handle an array of texture coordinates. We're then switching on texture 2D, GL texture 2D, so we're saying we're going to have a texture that we're going to want to apply to our image. We then bind our image, so we want to make sure that the image we're about to use is the image of, or the texture, sorry, we're about to use is the texture inside the image we're currently in. So we can take the name of the texture as we do here, and that's the OpenGL name as created and stored by the texture 2D class, and we can bind it. So we know that whatever we're about to do, it's going to use that texture to do it. We then say, okay, we now need to set up the quad vertices. So we set up this thing called vertex pointers. And this is used when you've got an array of vertices that you want to draw, okay? And this is how we're going to basically draw our quad on the screen. The things that are in here that are of interest, 2 means we're going to be taking 2 parameters, which is going to be X and Y. If you're in 3D space and you had an X, a Y, and a Z, you would say that each of these that's important is 3. So it'd be three locations within the array will be taken X, Y, Z, X, Y, Z, X, Y, Z, and so on. And we're saying the next argument here is defining the fact that each of the values inside the array are going to be floats. And then the last one over here is defining, sorry, this one here is an offset. Are you starting from the beginning of the array, or do you want to start from 2 into the array? So you can define an offset into the array you want to start the drawing. And then we actually say, and that's the array itself. So that's the array I want you to go and draw. Okay, from a vertex pointer point of view, which is the shape that we're going to draw. We then do exactly the same, except we use a texture coordinate or text coord pointer, and the same values, and it does exactly the same thing, except this time it's actually the texture coordinate. So this is saying these are the coordinates for the points that are going to define my shape. Text coordinate saying these are the points that define the location within the texture that I want to map into that shape. Okay. We then say we want to blend, so we want to be able to blend this onto the screen so that it handles things like alpha. So if you want to set the alpha of the color of something, you need to be able to blend it. So we're switching blending on. Okay. And then lastly, we're actually doing the draw arrays. And this is saying, well, we've got our vertex pointer and we've got our texture coordinate pointer. We've set up here this text coordinate array, so we know that texture coordinates are going to be important and used inside this draw arrays call. And we're then saying, and we're going to be using triangle strips. So this is what I was talking about earlier, where you actually are defining all of your shapes using triangles. And it's important because OpenGL ES doesn't support GL quad strip, okay, which would mean you define everything in quads. It only supports, for this type of work, triangle strip, so you define everything in triangles. Okay, and so we're defining the fact that that's the actual technique we're going to use, then there's an offset, and we're saying that we've got 4 points inside our arrays. Okay, so we've got 4 locations in the arrays that we're actually going to do for the 4 points that we're going to be reading from our arrays that we defined earlier. Okay, so again, I hope that makes sense. That's maybe not been described in the best possible way. Nihi and other websites do a really good job at letting you understand the basics of how all this OpenGL stuff hangs together and works. But I've given you a rough idea there. So this command is actually what physically draws the texture, the shape, and blending and everything to the screen. So that's now drawn. So because we're finished, we can then say now turn off blending by using GL disable. We can then turn off the texture 2D because the next operation may not want to use textures. And we can then turn off the texture coordinate because again, we may not want to apply texture next time we use draw arrays. So we're switching that off. And then lastly, we are popping the matrix. In other words, what we saved earlier on with push matrix, we're now popping. So it's going to return us back to the location we were before we did our translate. It's going to turn us back to the rotation we were before we did our rotation, and so on. So we've got a nice little self-contained unit there which says draw this to the screen, sorry, save the current settings, draw our image to the screen with its settings, and then revert back to the previous settings. Okay, and that's really it. So this is what I was talking about we've got one routine here inside this method, this render at method, that does all of the actual OpenGL to render to the screen. And then that's being called from within inside our, if we go slightly up, our render subimage at point, which defines the texture coordinates and the quad coordinates or quad vertices, and that in its turn is actually being called by render at point. So you can either call render subimage at point directly if you know of the size and the type of subimage you want to draw, or you can actually just say render the entire image and it will use the configuration inside the image to do that rendering as well. But the code is very straightforward. We only have to make changes to render subimage at point if we're changing the texture coordinates or the quad coordinates, and we only have to go and make changes at render at if we want to change any of the OpenGL. So I think that's fairly clean and sort of works quite well. So we'll save that. So that's really given us our method. We've now got our new image image class, which we can start to use. So at this point, I'm going to compile this just to make sure everything compiles okay, which it doesn't. We've got a few errors here, so let's go and hunt these down. Okay, so if we have a look, we've got an error here just before the texture 2D stuff, which we'll have a look at. Right, and what we can see is that I've actually got a missing import from here because it doesn't know what texture 2D is because we're actually using that. So I'm going to add an import here for our texture 2D. Okay, if we build again, okay, we can see that we've got a number of warnings here. Okay, may not respond to init implementation. All right, now the reason for that is that there's something else that I've forgotten here. So this has jumped back into our initialization routines, and you can remember we had this thing called self init implementation, which we have created, but we didn't actually define it in our header. So if I flick back to the header and scroll down, you see we didn't actually define that inside our header, and that's because it's private. It's something that we don't want to expose externally. So what that means is that we actually want to go and create that implementation, or that header if you like, internally inside our class. So what we can do is if we